Hey guys, welcome to your first Algebra 1 tutorial video. Before we get started on our first example, I do want to go over a couple things, or one thing mainly. Make sure that when we're working with equations that you keep the equation balanced at all times. Now, what I mean by that is, for example, if I add 3 to side 1 of my equation, please be sure to add 3 to side 2. Alright? If I were to subtract 5 from my side 1, make sure you also subtract 5 from side 2. Right? Same goes for division and multiplication. If I multiply times 7 on side 1, make sure you also multiply by 7 on side 2. And if I'm dividing side 1 by 4 as an example, make sure we divide side 2 by 4 as well. Our first example is going to be something simple. We're going to start with a one-step equation. So say we have x plus 3 is equal to 12. Alright, so what does it mean to solve an equation? To solve an equation, it means we're going to be isolating our variable. In this case, our variable is an x. We're going to isolate him or leave him alone. Now, the way we isolate our variable, the way we leave him alone, is by undoing the actions that are being done to him. Now, in this case, if we're looking at the x, we notice that we're adding 3 to him. So the way we undo these actions is by using the inverse operations. Now I'll go ahead and add the inverse operations up here on this right corner so you can see what they are, right? But it's pretty common sense, right? If we have plus 3, right, that's what's being done to the x variable. I'm going to go ahead and do the opposite or the inverse operation, which is to subtract 3. Now, based off what I said up here, when we're trying to keep our equation as a balance, right, whatever I do to side 1, or the left side, I'm going to make sure that I do it to the right side. So, plus 3 minus 3, these guys cancel out, and I'm left with only the variable x equals, on the right side I have 12 minus 3, so I'm left with 9. Now we've gotten to the point in our equation where our variable is isolated, our variable is by itself, so this right here would be my final answer. For our next example, we're going to have x minus 4 is equal to 7. So now, let's look at our variable, and we want to isolate him. We want to undo whatever's being done to him. Now in this case, we have minus 4, right? So using our inverse operations, we know that the inverse of subtraction is addition. So I'll go ahead and add 4. Now recall, whatever we do to side 1, we have to do to side 2. I'm left with, these guys cancel out, x is equal to 11. Now moving on, we have, I'm just going to go and make something up. Say we have 3x is equal to 15. Now in this case, if I look at the x variable, what is that 3 doing to the x? Right, when it's 3x, it's multiplying, right? It's multiplying. So what is the inverse operation of multiplication? It's going to be division. So I'm going to go ahead and undo this times 3 by dividing by 3. And recall, we want to keep our equation balanced, so I'm going to go ahead and divide both sides by 3. On the left side, these guys reduce to a 1. So I'm left with just 1x, or x. And on the right side, I'm left with 15 divided by 3, which is 5. One more example. I have, let's say, x divided by 2 is equal to 8. So once again, if we look at my variable x, he's not by himself on his side of the equation. We want to completely isolate him. We want him by himself on this left side. It doesn't matter what side he's on, but all 4 examples so far, the x has been on the left side. So I want him by himself on the left side. Now look at that 2. That 2 is dividing our variable x. So we want to do the inverse operation and multiply by 2. So I'm going to go ahead and multiply both sides by 2. Now I'll use that little circle looking thing to denote multiplication, right? I don't like using the little x because I don't want you confusing the x with the variable x, right? I don't want you confusing the multiplication x with the letter x, with the variable x. So I'll go ahead and use that little circle from now on. So if we're dividing by 2, the opposite of division of 2 is a multiplication of 2. Now again, keep in mind that whatever you do to one side, you do to the other side. All right, that probably should have been a little higher up. Anyways, these guys, since they're opposites of each other, they're inverses of each other, they reduce to a 1, they're gone, and I'm left with x is equal to 16. So for the second half of our video, we're going to be moving on to two-step equations. Now, why are they called two-step equations? It should be pretty self-explanatory, but they're called two-step equations because it requires 2 steps to get an answer. Now, what do I mean by that? Right? If you go back to these one-step equations up here, right? All I had to do was undo one operation. So, for example, plus 3, all I had to do was subtract 3 to both sides, and I got my answer. It was only one step. Here, all I have to do was add 4 to both sides, and I got my answer. Here, all I have to do was divide both sides by 3, and I got my answer. And here, all I have to do was multiply both sides by 2, and I got my answer. It only required one step. Now, for two-step equations, you got it, right? It's going to require 2 steps. It's going to require 2 operations that we have to undo. Now, the problem arises when we have 2 operations that we have to undo. What order are we going to undo them in? And that's when the order of operations, which I'll add right here, comes into play. Now the order of operations, right? You've known it as PEMDAS. I'll talk about it as GEMDAS in this class. The order of operations tells you in which order we have to do our operations in order to simplify an equation, right? But in order to solve an equation, we're undoing things, right? We're undoing these operations. So if GEMDAS is the order that we have to do to simplify an expression, to do an equation, to undo it, we're going to have to go backwards. We're going to have to go from bottom to top. So if we're looking at 2x minus 7 equals to 11, and we're starting from the bottom of our order of operations, we have the adding and subtracting at the bottom. So first things first, I'm going to have to get rid of this minus 7 using our inverse operations. So what is the inverse of minus 7? What is the opposite of subtracting 7? We're going to go ahead and add 7. But make sure we do it to both sides. So I add 7 to both sides, and I'm left with, these guys cancel out, 2x is equal to 18. Now you notice one thing. I've done one step, right, of the 2 steps required. Now I'm only left with one more step. Now this just looks similar to, for example, this example right here, right? Because we only have one step left to go before we solve it. So looking at 2 times x equals 18, the inverse of multiplying by 2 is going to be divide by 2, and divide by 2. These guys simplify. They're done. They reduce to a 1. And I'm left with x equals to 9. For the next example, we have x. Let me circle this, or square it, box it in. For the next example, we're going to have x divided by 2 let's say minus 4 equals to, let's say 5. Alright, so once again, we want to solve this equation. Now again, to solve an equation means we want this variable x by himself on his side of the equation. Now using our order of operations, right, we know that we're trying to undo these two operations. So we're starting from the bottom. So what comes first? Division or subtraction? What comes first if you're coming from the bottom? The minus 4. Right? So we need to undo this minus 4 first. Now I'm going to go ahead and add 4. That's the opposite of minus 4. And what you do to one side, you do to the other. Now keep in mind, we're trying to keep it balanced. So I'm only going to add 4 once here and once there. Now these guys cancel out. And I'm left with just x divided by 2 is equal to 5 plus 4 is 9. Now we're not done because our variable is not by himself on his side of the equation. We still have x divided by 2. So what is the opposite or the inverse of a division of 2? It's going to be a multiplication of 2. A multiplication of 2. What you do to one side, you do to the other. These guys are going to reduce completely. And I'm left with x equals to 18. And that right there is my answer. Alright, but now let's get to the complicated thing, or what makes two-step equations a little bit more complicated. So let me go to the next page. I'll use the whole page. What makes two-step equations a little complicated is the grouping, right? The very top of our order of operations, the parentheses. Now, normally, in middle school or in elementary, we learn that we must always do whatever's in parentheses first, right? We must always do what's in parentheses first. But because we're undoing, make sure that you leave whatever's inside parentheses or in its group till the very end. So to start off, let's give an example of 2. Let's say it's x plus 4 is equal to, let's say 6. Right, so if I look at my variable x, and I'll go ahead and split up my equation already from left and right side, or side 1 and side 2. If I look at my variable x, I want him by himself on his side of the equation. Now he's not alone, right? There's a 2 and there's a 4 bothering him. Now, normally you guys will look at this and think, well, the plus 4 right here, he's at the bottom of my order of operations, right? So he would go first, because this is adding 4 and this is multiplying by 2. Now I know there's no multiplication here, but you should know by now that whenever you have a number outside of parentheses, that number is multiplying with that parentheses. So normally you would look at this and be like, okay, well, we have a multiplication and we have an addition, and because addition, when we're undoing it, it's on the bottom, right? It's near the bottom of the order of operations. That would come first. But that addition right there, he's inside of parentheses. Now, if you look at your order of operations, you should notice that your groups or your parentheses are at the very top. So what that means is you leave parentheses alone till the very end. So we're not going to mess with this plus 4 yet. What we're going to do is we're going to try to undo this times 2. Now, how do I undo a times 2? What is the inverse of times 2? Alright, I'm going to go ahead and divide by 2. Now I'm going to go ahead and divide the entire side by 2. Alright, I'm only doing it one time. Alright, I'm only going to do it one time. So I'm dividing the left side by 2, which means I have to divide the right side by 2. Now, these guys reduce, they're gone. And I'm left with x plus 4, right, is equal to 6 divided by 2, which is 3. Now notice I remove the parentheses because there's no longer a reason to have a parentheses there. The 2 on the output is gone. So it's just x plus 4. Now again, our variable x still isn't alone. There's still a plus 4 with him, right? So how do I undo a plus 4? I'm going to go ahead and subtract 4 from both sides. Subtract 4 from both sides, right? So 4 minus 4, those guys cancel out. That's a 0. X equals 2. Now what's 3 minus 4? That's negative 1. Now this is a little bit more complicated, I understand, because of these parentheses, and it kind of tricks you into thinking that we have to get rid of this plus 4 first. But keep in mind, whenever you have a grouping symbol, whenever we're undoing, right, if we have a grouping symbol, such as a parentheses or a bracket, we're going to have to leave those to the very end, because parentheses is at the very top of our order of operations, so he should be the last thing that we're doing when we're undoing our operations. Alright, so for our last example, let's say we have x plus 2 divided by 3 is equal to 7. So for our last example, we have x plus 2 divided by 3 equals to 7. Now this is similar to the last problem where there is going to be some kind of trickery involved, right? There might be some confusion involved. But if you look at this, normally you'd think, okay, well we have a division of 3 and an addition of 2, and since addition is at the bottom, right, of our order of operations, that is what we're going to undo first. But in reality, in algebra, the fraction bar, it pretty much is automatically grouping the top and the bottom. Now, it's invisible, right? So I know what you guys might be thinking, right? But this is an invisible set of parentheses here, and I mean, if you want, you could do an invisible set of parentheses at the bottom, right? Covering the speak, but it's only one thing on the bottom, so I don't really have to put a parentheses, right? But in algebra, just understand, and if you notice at the little gamma sign, right, it says parentheses, brackets, so on and so on, and the fraction bar. So what the fraction bar does in algebra is that it automatically groups the top with the top and the bottom with the bottom. Alright, so let me go ahead and rewrite this again. So we got x plus 2 over 3, or divided by 3 is equal to 7. So once again, these top guys are a group on their own, right? And this guy in the bottom, he's in his own little group. So the fraction bar is creating two groups, right? One up here and one down here. Now we don't really have a group on the bottom because he's by himself, but these two guys up here are grouped together. So because they are grouped, and I'll go ahead and do the parentheses again. Because they are grouped, I'm going to leave them to the very end. Alright, so I need to get rid of this division of 3 first. So how do I undo, or what's the opposite of dividing by 3? We're going to go ahead and multiply both sides by 3. Right? Now on the left side, these guys are going to reduce. They're gone. So we're left with only x plus 2 is equal to 7 times 3 is 21. Now the last thing I'm going to do is I have x plus 2. So I'm going to go ahead and subtract 2 from both sides. And I'm left with x equals to 19. And that right there is my final answer. Now again, this one's a little bit more complicated just due to the fact that we don't really have parentheses, but they're invisible. They're invisible parentheses there. So whenever you see a fraction bar with more than one thing on top or more than one thing in the bottom, understand that those things are grouped. So whenever you see a fraction bar, the top is grouped with the top and the bottom is grouped with the bottom. Now like I said, in this case, we only have one thing by himself on the bottom, so we don't really have to group him. But we did have two things on top, so these were grouped. So they are left to the very end. They're considered part of a grouping symbol, right? And so that's why I added the parentheses. So there's like imaginary parentheses on fraction bars. So I know that two steps are a little more complicated than one-step equations, but if you just, take some time and actually look at your equation that's given to you, and you use the reverse order of operations. All right, it should be pretty easy. So don't overcomplicate things. I know it gets kind of complicated once we look at the groupings, right? But just be very, very cautious of the groupings, right? Make sure that if you see a parentheses, you leave it. Oops, sorry. Make sure if you see a parentheses, you leave it till the end, and make sure if you see a fraction bar, pay close attention. All right, if you see a fraction bar, pay close attention to see if there's groups on top or groups on the bottom. Remember, if there's more than one thing on either top or bottom, it automatically becomes a group. All right. So that's gonna be it for today's lesson, guys. So just please be sure to practice your problems. You're gonna have an assignment with 5 1-step equations and 5 2-step equations, right? But as long as you continue practicing, this I promise you this will get easier. If you have any questions, please don't forget to fill out the Google Forms on the help button on my homepage, right? But other than that, guys, I'll see you in class. Bye.